Welcome everyone, this is Aryan Choudhary and you are watching Let's Crack JEE. So, so, so this is the seventh lesson on our Alkyl Halide. This is the last lesson of this chapter. In today's session we'll be finishing off this chapter. Okay. So if you are new to this channel and you are watching my video for the first time, let me introduce myself. I am Aryan Choudhary. I am a BTech graduate from IIT Dhanbad. I cleared JEE in the year 2016. Okay. So let me tell you about this course. This is a course for all the students who are giving their JEE in the year 2021 as well as in the year 2022. So today's session will be the last session on the alkyl halide. So we'll be finishing off alkyl halide in our today's session. So the thing is, from tomorrow onwards, what we will do is we will start a new topic, that is the alcohols. Okay. Alcohols, phenols. We'll be starting this topic from tomorrow, that is tomorrow at 4 p.m. है ना. So I was thinking, since we are only covering the organic portion, अभी अपन क्या करेंगे ना, अपन अब classes alternate days को लेंगे. So जैसे कि अपना कल we will be taking a session on organic chemistry, that is alcohol, phenol. So day after tomorrow I'll be starting a new topic, that is S block. Okay. So we'll be having the sessions on the alternate days. एक दिन अपन ऑर्गेनिक करेंगे and on the next day we'll be doing inorganic. So this thing is from 12th standard and this is from your 11th standard. And since I have told you over and over कि it's very important to get into an habit of solving questions, because finally आपके practice पे depend करता है that how much you will be going to score in your JEE. So this practice is very important. ठीक है, that is why what we are doing is we will be solving questions in my special classes. Okay, so today I took a session on periodic properties. We solved around 25 questions in this session. Tomorrow again at 2:30 p.m. I'll be taking a special class in which we'll be solving question on this topic, that is periodic properties. So अपन आराम से क्वेश्चन करेंगे. कल if possible I'll be taking 2 special class. In one of the special class we'll be solving question on periodic properties and in the second one we'll be solving questions on alkyl halide. So since we have completed this chapter, I'll be taking a session जहाँ पे अपन ये भी cover करें, and since day after tomorrow we'll be starting inorganic chemistry, तो उसके base के लिए it's very important to do the chapter of periodic properties and chemical bonding. So these two chapters are very important if we are going to study S block. So that is why I want everyone to revise these two chapters. ठीक है. So I'll be taking special classes जिसमें अपन इस पे क्वेश्चन सॉल्व करेंगे. And coming on this Saturday पे I will take a marathon session जहाँ पे अपन ये चीज़ें रिवाइज भी कर लेंगे. Okay. So I hope all of these part is understood by everyone. So let's start our today's session, that is alkyl halide. ठीक है. And before that, let me tell you about the Unacademy Plus subscription. So since we are studying on YouTube, है ना, यहाँ पे the learning is not that fun. यहाँ पे we are not able to interact with each other. So if you want a place जहाँ पे you want to interact with your teacher, you want to get the feel of a classroom teaching, then you should definitely take the Plus subscription. So let me tell you about the things that you get from the subscription. तो आपकी ना, what will happen is you will have daily life classes in which you can directly interact with your teacher. You can ask doubts to them, you can talk to them regarding anything. ठीक है. It will be a totally classroom like environment. Next thing is structured courses. So this is very important. It's very important to study everything that we study in a very proper manner. The thing is, the syllabus is very huge for the JEE, right? So we need a system through which we can properly cover everything and will not get confused कि मुझे आज क्या पढ़ना चाहिए and on the next day what I have to study. That is why the structuring is very important. So once you take the Plus subscription, all of these things will be done by us. The best part about the subscription is live tests and quizzes. The thing is, you need to get into a habit of solving these questions, है ना. The reason is because in your examination you have to solve questions to get good marks, right? To get into IIT you need to solve questions. So that is why I always recommend everyone to solve a lot of questions on all the topics, because once you will get habituated to solving those questions ना, तो you will feel very confident in your examination. You will understand कि कहाँ पे मेरे silly mistakes हो रहे हैं. So with this plus subscription in a 2-year span, you'll be giving more than 100 tests like JEE, so which will boost up your confidence when you will be giving your final examination in the JEE paper. Okay, and on the basis of these tests, you can also evaluate whether you have studied properly, or whether you are lacking something, or you are struggling in some part of a particular topic. And if you feel like that you are suffering, so what you can do is you can go back to the Unacademy channel, and or on the Unacademy app, you can view as many videos on that particular topic, है ना. So say you will get a better understanding about that topic, and you can improve on that topic, right? And if you want to see the same video that you have seen in the starting, you can again watch that video, right? So these things are very important. These things you will get from this subscription. So let's understand how to take the subscription. So the first step is download the Unacademy learning app from the Play Store. I hope everyone knows how to download an app. Next thing is you need to choose a plan for yourself. The first thing that you need to decide is whether you want to take the plus subscription or you want to take the iconic subscription. So things that I have just described were for the plus subscription. Okay, so iconic subscription is a better version of plus. So I'll be telling you about the things that you get in that subscription. But first, in the plus subscription, if you take a 1-year subscription, the cost is 38,500, but it will drop to 34,650 once you use my code, which is AC01. This code is providing you with a 10% discount. Okay, while if you take a 2-year subscription, the price is 56,000, it will drop to 50,400. Okay, again you need to use my code. This code is providing you this 10% discount. Okay, so we have discussed everything about the plus subscription. If you have any doubt, you can always let me know in the comments. Next thing is your iconic subscription. So the thing is, with the iconic subscription, we offer a lot of different things. The thing is, you'll be getting a personal coach who will be guiding you throughout the process, who will be talking to you, will be understanding the main problem that you are facing. Okay, he'll be your study partner. You will have a one-to-one session with him. Okay, he'll be guiding you on each of the topics that you will be studying, and he will do the test analysis with you, so that he will understand on which part you are lacking, and he will suggest you to watch, or he will suggest you to revise that particular concept again. So I hope everything is clear to everyone. Okay, so let's start our today's topic. Okay, so this is the last lesson on alkyl halide. We have covered a lot of different things in the past 6 sessions. Okay, Vaishnavi is asking some doubts. Sir, can you tell me this question's answer? Q rate of I am not able to understand your question, Vaishnavi. Q rate, what is answer of Q rate of SN2 reaction mechanism? Okay, so if an image is attached to this question, what you can do is tomorrow at 2:30 p.m. I'll be taking a special class. आज भी एक session लिया था in which we have solved questions on periodic properties. So you can join in this session tomorrow at 2:30 p.m. and you can ask the same question again in that session. Okay, so what is the question? I'm not able to understand the question, Vaishnavi. Chali, we will start this session. So in yesterday's session, we have discussed few things about your aryl halide. We have seen the preparation of aryl halide, that your normal aryl halide cannot be prepared by normal chlorination or bromination. So to prepare your aryl halide, we used a process that is known as electrophilic aromatic substitution. So what we did in electrophilic aromatic substitution, we added chlorine in the presence of a Lewis acid. So this Lewis acid is very important. This Lewis acid is increasing the electrophilicity rate. Okay, rate of SN2 reaction mechanism is minimum in. Okay, you need something to compare of, right? So आपके पास कुछ तो चाहिए ना कि किस चीज़ों के का कंपेयर कर रहे हो. कि रेट ऑफ SN2 रिएक्शन इज मिनिमम. अगर आप नॉर्मल एल्काइल हैलाइड की बात करो तो योर 1 डिग्री एल्काइल हैलाइड दैट इज योर CH3X, this undergo SN2 reaction mechanism very fastly compared to your 1 degree alkyl halide, then your 2 degree alkyl halide, and आपका जो 3 degree alkyl halide है यहाँ पे you don't have SN2 reaction mechanism. If you have your 3 degree alkyl halide, that will not undergo via your SN2 reaction mechanism. Unable to give options. Okay, so this is the thing. So if you have an alkyl halide which is something like this CH3Br, next thing is you have, if you have this thing, okay, and at the last if you have this species, the rate will be maximum in this case. Then in this case this will be the first, this is first, this is second, and यहाँ पे you will not have SN2. Okay, so what you can do is, Vaishnavi, just tell me the question number. I will explain you in the next session. ठीक है, आप क्वेश्चन नंबर बता दो. Okay, so let's talk about electrophilic aromatic substitution. So here we need a Lewis acid which is increasing the, which is making this chlorine bond break heterolytically, that is this chlorine is taking the electron and we are creating a chlorine positive. So what can happen is this bond can open up in one direction and act as a nucleophile and it will attack on this chlorine. So this whole process is known as electrophilic aromatic substitution. So your chlorine is the electrophile here, okay, and this aromatic substance has a tendency to polarize and it is attracting this chlorine. So finally you are creating your aryl halide, that is your aromatic halide. Similarly you can do this reaction with bromine. You can use FeCl3, FeBr3, AlCl3. You can use any Lewis acid in this case. So you just need to understand the use of these Lewis acid here. So Vaishnavi, third question in the chapter of alkyl halide, level 1, right? So alkyl halide, question number 3, level 1, right? So this is the question that you are asking, right? I will let you know about it in tomorrow's session. Okay, so I hope this process is clear to everyone. We have seen these examples. यहाँ पे आपके पास simply you will get this thing. So if you haven't watched my yesterday's session, वहाँ पे मैंने ये चीज़ें explain किया है. Okay, simply you will be getting this thing. We have seen कि if there is a presence of a group onto the benzene ring, so this group will affect the position where your halogens will get attached to this benzene ring, right? So अपन ने discuss किया था कि that this is the plus M group, right? It is providing electron to the system. So all the plus M groups are your ortho para directing for an electrophile. Okay, so in this case you will be getting two products. In one case your bromine will be on ortho position, and in the second case the bromine will be on para position. Okay, so within few minutes we'll be discussing the few reactions of alkyl halide and we'll be also doing the SNAR reaction. Okay, so I am just revising the few things that were very important that we discussed in our yesterday's session. Okay, next thing is we have seen the case of NO2. This is a minus M group, right? It is a minus M group, so it is meta directing. We have seen the reaction mechanism of all of these reactions in our yesterday's session. Okay, this is a meta directing group. Okay, so in this case your bromine will be added on the meta position to this NO2 group, right? So देखो, we are learning different ways in which you can have substitution at different positions, right? So if you want the bromine on the ortho para position, you can use a plus M group. So these processes are very important to understand because you are learning how to make different products, right? So we have seen how to substitute your bromine at orthopara position. So if you want a meta substituted bromine, so you need a minus M group here. Okay, so these things are very, very important. And we have also seen this case, that is your chlorine, that we have discussed that your halogens have plus M, right, and minus I. These deactivate the ring, but they are orthopara directing. Okay, so these points are very important. Even though your chlorines are deactivating groups, still it is an orthopara directing substituent. ठीक है, तो यहाँ पे अगर आपका क्लोरीन का एडिशन होगा ना, तो you will have the chlorine here either on the para position or on the ortho position. Generally आपका para position are more stable, right, because you have less steric hindrance there. Okay, so I hope all of these things are clear to everyone. So we have seen all of these cases. चलिए, this reaction is very important. अपन ने कल ज़्यादा डिस्कस नहीं किया था इस रिएक्शन के बारे में. So this reaction, Sandmeyer reaction, is very important reaction. You can prepare a lot of different compound using this reaction. So in the chapter of alkyl halide, we'll be mainly focusing on the preparation of your aryl halide. Here in the first step, what we do is we prepare a diazotized diazonium salt. ठीक है? We prepare diazonium salt. This preparation is very important. What we do is we start with aniline. Once you start with aniline, you add NaNO2 and aqueous HCl into it. So once you add both of these two, from here what you will be generating is you will be generating this NO. ठीक है? Now this NO is a very odd electron species. This is very reactive. This NO will attack on this aniline to form your diazonium salt. And once you have created this diazonium salt, ठीक है, the nature of your diazonium salt is that this N2 can leave by taking the electron. ठीक है, that is why we keep the temperature at a very low. We keep the temperature. Sir, is anything possible? Okay. What do you mean by that? सही से पूछो यार. ठीक है, once you have created your diazonium salt, उसके बाद you can add any reagent which will replace this N2. ठीक है, we are discussing that the temperature should be very low. It should be around 0 to 5 degrees Celsius. Because if you increase the temperature now, so what will happen is this bond will break, this N2 will leave. That is why we are providing very less energy in this reaction so that it remains as it is. ठीक है, and once we add some reagent, finally we will get an alkyl halide. So if you add CuBr, so there will be a bromine here. Okay, so this reaction is used for CuBr, Cui and Cu chloride. You cannot prepare an aryl fluoride using this reaction, so you need different reagent. ठीक है, so here is the reaction mechanism of your Sandmeyer's reaction. We have discussed this in our yesterday session. ठीक है, we have discussed this is a very good leaving group. This can leave anytime, creating a positive charge on your phenyl, है ना. Next thing is to create your aryl fluoride, you need a reagent that is HbF4. So once you have prepared a diazonium salt, just add this HbF4. This will add a fluorine onto this carbon. Okay, so this page is very important. So we started with aniline, we are creating the diazonium salt. Now depending upon different reagent you use, you can create different types of product. Okay, so your diazonium salts are used a lot of time to prepare different product. We have seen this reaction. Okay, you can also use Ki, which is a process to create your aryl iodide. Okay, you can also create cyanide and phenol using the Sandmeyer's process. So we will be discussing about these two reactions in the further chapter. We will see this in the next chapter, that is your alcohols and phenols. Okay, chaliye, we have done this question 2, right? So this question has been done. Let's start something new of on this session, that is your Borodin Hunziker reaction. This is again one of the important reactions of this chapter. Okay, so this reaction is also studied in the chapter of carboxylic acid. The two main thing about this reaction is it is a test for carbonyl. Okay, it is a test for carbonyl and it is a step down reaction. Okay, so what we are doing is we are taking a silver salt of a carboxylic acid, we are reacting it with Br2 in CCl4. This is your non-polar solvent. Okay, and finally you are getting RBr. ठीक है, आपका यहाँ से this is getting removed. This thing is removed to create your alkyl halide. Okay, AgBr is the precipitate here, and you are getting CO2. So we will understand the mechanism of this process in a while. Okay, so this is a test for carbonyl. It is a step down reaction. What do I mean by this statement is, देखो, one of the carbon that was present in the substrate has lost in the form of CO2. So the number of carbon that was present in the substrate is more than the number of carbon that we have in the product, right? So let's try to understand the reaction mechanism. So we have, let's take one example of so this is the carboxylic acid that we are using. We have salt, we have Ag plus. And the first thing is we are adding Br2. So guys, after doing these few reactions, we'll be also try to understand the reaction mechanism, that is your SNAR reaction mechanism. Okay, so just wait for that. So what will happen here is, देखो, we know that कि आपका जो Ag है ना, Ag is used for the test of bromine. AgBr precipitate very easily. So once you add bromine into the substrate, what will happen is one of the bromine will take both the electron and it will form a bond with this Ag to form AgBr. So since we are creating this AgBr, there will be a bromine जिसके ऊपर you will have a positive charge. Okay, so since this bromine has a positive charge, we know we have an oxygen जिसके ऊपर negative charge है. This negative charge can attack on this bromine. It can form a bond with this bromine. तो यहाँ पे ना you will create a species that will look CH3 C double bond O. You have oxygen here and a bromine here. So you have created this thing. Once you have created this thing, अभी यहाँ पे ना कुछ weird चीज़ें होती हैं यार. These things are not totally understandable. But the thing is, यहाँ पे क्या होता है? यहाँ पे this bond breaks homolytically. Okay, so I will just mute everything. चलिए, so this bond is breaking homolytically. This is your, यहाँ पे ना we are creating free radicals. So from here you will be creating a bromine radical, and यहाँ से you will have CH3 C double bonded oxygen and and a radical on this oxygen. Okay, once you have created this, ठीक है, yeah, Pooja is saying just dislike this video. Yeah, you can definitely do that, but the thing is, nobody has asked you to join this session, है ना? So there are people who are watching this video. If you want to spread hate in this system, you can definitely do that. But the thing is, देखो, you will never get benefit from that. Okay, so you can do whatever you can. So if you know about YouTube, ठीक है, ज़्यादा कुछ होता नहीं है यार if you do a dislike on the video. Okay, so there are people who do watch my video, so I don't have to worry about that. चलिए, so once you have created this thing, okay, we have created this thing, इसके बाद ना एक और चीज़ें होती हैं. The thing is कि आपका जो ये बॉन्ड है, even this bonds break homolytically, ठीक है, this breaks homolytically to create carbon dioxide. Here you will have O radical and a radical on this carbon. यहाँ से we are generating a CO2. Now the thing is, we are generating a CH3 radical. Generally these are not that stable, but since in the solution we have this bromine radical, this bromine radical can react with this CH3 to form CH3. This was the desired product that we wanted, right? So you have created your alkyl halide, a CO2 has been evaporated, okay, and AgBr has precipitated. So this reaction is very important. You will see the use of this reaction in a lot of different ways in this chapter, okay. So if you have anything to ask, you can always say that in the live chat. So I'm seeing towards the chat. Okay, moving on to the next reaction, we have covered one of the important reaction, that was your Borodin-Hunsdiker reaction. So if anyone have any doubt regarding this reaction, you can always ask. Next thing is your Williamson ether synthesis. Okay, so again this is one of the reactions. This is the preparation of ether using alkyl halide, right? So we have seen a lot of different reactions where अपन ने देखा कि how to create different products using your alkyl halide, है ना? So this chapter is very important. You will see that your alkyl halide are used to prepare a lot of different products. So we have seen the preparation of alkyl halide. We have seen a lot of reactions using our alkyl halide, and this is again a reaction where we are starting with an alkyl halide. Okay, we are adding a nucleophile here, and finally we are creating our ether. So what is happening here is this reaction is a normal substitution reaction. So over the course we have studied, okay, over the course we have studied कि आपके जो alkyl halide है ना, आपके जो halogens हैं, they are very good leaving group, right? So they have a tendency that they can lose. Okay, if you are asking about my qualification, I cleared my JEE in the year 2016. Okay, I am a IIT Dhanbad pass out. Okay, I passed out from IIT Dhanbad in the year 2020. पूछो देव यार, there is nothing that I can say to you apart from laughing on you. If you are here just wasting your time, if you are just here to spread negativity, so I cannot do anything apart from laughing on you. Okay, so I did clear my JEE. I am a pass out from IIT Dhanbad. I definitely have a better life than you. चलिए, so let's come back to guys. So it's very important ना life में ना देखो, yeah, we are here to study the portion of the 11th-12th standard, but the thing is life में it's very important to be a good person, right? So if you are just going everywhere to just spread hate and आप बस लोगों को बुरा बोल रहे हो, तो it will come back to you in somehow, ठीक है? Maybe you will not able to understand these things right now, but you will see in the future, you will see in your life. Okay, Sarita Jain is asking Dhanbad कहाँ पे है? Sarita, Dhanbad is in Jharkhand. Okay. So the college initially used to known as ISM. Okay. So in the year 2016, it got it converted into IIT. So now it is IIT ISM. Okay. So let's try to understand here. So here what we are using is, यहाँ पे we are starting, देखो मैं यहाँ पे आपको पूरा reaction mechanism समझाता हूँ. The thing is, we are starting with this thing, a negative charge on this oxygen, right? This is a salt, right? So we can neglect this sodium. Okay, now this negative charge, this can act as a nucleophile, right? And we have just understood ठीक है, we have a chlorine, we know that your halogens have a tendency to leave. So what will happen is this O negative can attack on this carbon and this chlorine will leave, right? Simple, this is a substitution reaction, है ना? This is like your SN2 reaction mechanism. So you can note down this, that is your Williamson ether synthesis is a SN2 reaction mechanism. So that is why you would need the alkyl halide that you are using. It should be a 1 degree alkyl halide. अगर ना आप 2 डिग्री या 3 डिग्री यूज करोगे तो द थिंग दैट विल हैपन हियर इज कि आपके SN1 के चांसेस भी इंक्रीज होते जाते हैं. सो SN1 के चांसेस इंक्रीज हो रहे हैं, मतलब आपका एलिमिनेशन के चांसेस भी इंक्रीज हो रहे हैं. ठीक है, we will do a bunch of examples after this where we will understand कि why you need a 1 degree alkyl halide here to form your ethers. Okay, so we are just using a salt of sodium alkoxide जो अपने को एक न्यूक्लियोफाइल प्रोवाइड कर रहा है. दिस न्यूक्लियोफाइल कैन अटैक हियर एंड दिस क्लोरीन इज लीविंग. फाइनली वी आर गेटिंग आवर ईथर. सो दीज टू आर डिफरेंट एग्जांपल्स हियर. यू कैन क्रिएट योर डाइथाइल ईथर, है ना. सो जनरली ना आपके जो ईथर्स होते हैं ना, दीज आर यूज्ड एज अ सॉल्वेंट. अपन ने देखा था इन द केस ऑफ ग्रिनार्ड रिएजेंट. So in the case of Grignard reagent, we were using diethyl ether as the solvent, है ना. We needed a dry ether, right? In the case of Grignard reagent. So your ethers has that. Okay, मेरे marks. देखो, I don't remember the marks that I got in my examination, but my rank was 8,832. So this was my JEE advanced rank. Okay. So we have understood about the Williamson ether synthesis. Now the next thing, here we will see a bunch of examples. So what is happening here is, देखो, यहाँ पे we are using this. So this is like this thing. I am just drawing the bond line formula. This thing is like O negative, right? So this is a very bulky group. And we have studied in the chapter of reaction mechanism, if you have a bulky group which has a negative charge on it, generally try to act as a base. But the thing is, and if it is acting as a base, तो आपके elimination reactions होंगे. Okay, what the thing is, यहाँ पे you don't have the possibility of elimination. The only thing that can happen here is this negative charge will attack on this carbon and this bromine will leave, right? So this reaction is happening via your SN2 reaction mechanism. This thing is very important, that it is happening via your SN2 reaction mechanism. And finally, you will create a species that will look something like this. Okay. So this is the ether that we have created using these two, where your alkyl halide, this was a this is not even a 1 degree alkyl halide, right? This carbon is a methyl bromide, right? This is a methyl bromide. So अगर आप यहाँ पे ऐसे reactions करोगे तो you will get the ether, right? Now let's try to take a different case. So in this case, what is happening is, okay, यहाँ पे you have bromine. Okay, so you have 3 degree alkyl halide. You are starting with a 3 degree alkyl halide, and you are adding this base or the nucleophile. It can act. We know that key bases and these things can act either as a base or it can act as a nucleophile. Now the thing that is important is the conditions these reactions were happening via your SN2 reaction mechanism. ठीक है. Now अपने को पता है कि अगर आपके पास रिएक्शन में SN2 की पॉसिबिलिटी है तो you also have the possibility of E2. These two reactions have the similar conditions, right? तो यहाँ पे what we are creating is we are creating CH3O negative. Now the thing is, देखो यहाँ पे आपका SN1 तो नहीं हो रहा है, बट अगर आपका SN2 कराना है तो आपको बैक साइड अटैक करना पड़ेगा. बट इफ यू आर डूइंग द बैक साइड अटैक, देयर इज अ लॉट ऑफ स्टेरिक हिंड्रेंस इन दिस केस, सो यू कैन नॉट हैव अ बैक साइड अटैक हियर, है ना. सो अपने को पता है द ऑर्डर फॉर SN2 रिएक्शन इज दिस थिंग. Okay, since it is a 3 degree alkyl halide, so you cannot have a SN2 reaction in this case. The only thing that can happen here is your E2 elimination. तो यहाँ पे क्या होगा ना कि आपका जो negative charge है, this will act as a base. Okay, this is acting as a base. It will capture one of the hydrogen on the beta position. तो यहाँ पे let's say we have a hydrogen. So this CH3O negative will attack on this hydrogen, and this hydrogen will be taken by this CH3O negative. So you will create a species. मैं वापस bond line formula draw करूँगा. So you will create a negative charge here. So as soon as you will create a negative charge here, this bromine, okay, so this bromine will leave, creating a positive charge on this carbon, है ना? So if it will create a positive charge here, so you will get an alkene. You will have a double bond here. So यहाँ पे आपका elimination product form हो रहा है. Okay. So depending upon the type of alkyl halide that you are using, okay, you can have either the substitution product, okay, so यहाँ पे you are having the elimination product, while here in this case अपन ने देखा था कि यहाँ पे आपका substitution हो रहा है. Okay, so we have seen these reactions. ठीक है. The next thing that we'll be doing is we'll be doing few more reactions which are very important. Okay, so we have seen the Woods reaction in our yesterday session, जहाँ पे अपन ने देखा था, you must have remembered this session. ठीक है, जहाँ पे अपन ने देखा था कि simply you add an alkyl halide, you take an alkyl halide, you add sodium to it, you will finally get an alkane out of it. We have seen these reactions. ठीक है, यहाँ पे what we were doing is we were taking normal alkyl halide. That is, I will give you one example. Let's say we are taking this thing, we are adding sodium to it, plus we are adding this chlorine. So if you add 2 of the sodium, the final product that we were getting is, okay, I have drawn one extra carbon here. Okay, so we were starting with ethyl chloride and finally we are forming butane. So all of these reactions are similar to your Woods reaction. The only thing in the Fittig reaction, देखो, let's try to do these reactions one by one. So this is the case of your Fittig reaction. So what is happening in the Fittig reaction? Instead of using the alkyl halide, we are using aryl halide. So we have seen the preparation of aryl halide in the starting of this video. Okay, we have seen the preparation, है ना? So once you will create your aryl halide and if you react it with sodium, so you will get a binary aryl halide. Sorry, you will have this will be similar to your Woods reaction. So let's take one example. Let's say we are taking this thing. We are taking a benzene which has a chlorine to it, and we are adding 2 sodium, and let's say we have another benzene which has chlorine to it. So यहाँ पे आपके reactions के बाद you will get this as the final product. That is all. You have 2 benzene ring. Okay, just wait for a minute, guys. Adi Shende, I don't even know him, guys. So I have started teaching on this platform from 1.5 months only. So yeah, Adi Shinde, there are people who just like to spread negativity in the environment. So this guy is something like that only. Okay. The first, if you see his way of talking, you will also understand that he's saying that he's from IIT Bombay. So if he's from IIT Bombay, what is he doing in this session? And I have been teaching for only 1.5 months. Okay. And if he is from IIT Bombay, he must have guided his brother, right? Okay. चलिए, नेक्स्ट थिंग इज वी हैव अंडरस्टूड द रिएक्शन ऑफ फिटिंग रिएक्शन. सो देखो सिंपल ही है, वुड्स रिएक्शन जैसा ही है. यहाँ पे वी आर यूजिंग नॉर्मल एल्काइल हैलाइड, यहाँ पे वी आर यूजिंग अराइल हैलाइड. सो द सेम थिंग इज हैपनिंग हियर. ठीक है. द नेक्स्ट थिंग इज, ठीक है, नेक्स्ट थिंग इज योर वुड्स फिटिंग रिएक्शन. ठीक है, वुड्स फिटिंग, इन द वुड्स फिटिंग रिएक्शन व्हाट इज हैपनिंग इज वी आर टेकिंग अ अराइल हैलाइड and we are taking a alkyl halide. Okay, so if you take any of these reagents and you react with sodium, तो आपके पास you are getting this type of product. So what we are doing is it's just that देखो mechanism is same in all of these reactions. ठीक है. So this is one reagent that we are using, and next thing is we are using CS3. We are, let's say these are the two different alkyl halide we have. This is the normal alkyl halide and this is the aryl halide. So from this you will be getting this as the final product. Okay, so this reaction is known as your Woods Fittig reaction. So it's just that the mechanism is same for all of these things. It's just that in one of the cases we are using the alkyl halide and alkyl halide. That was the case of Woods reaction. In the fitting reaction we are using aryl halide, while in Woods fitting we are using one aryl and one alkyl halide. Okay, so similarly देखो there is one more reaction, that is your Ullmann reaction, where what we देखो अभी तक अपन क्या कर रहे थे, we were using only sodium to do these reactions, but you can also use copper to do these reactions. ठीक है, तो यहाँ पे कॉपर भी सेम चीजें कर रहा है जो आपका सोडियम कर रहा था. दिस इज ऑल्सो प्रोवाइडिंग this providing electron to the system. Okay, चलिए, we will be moving on to the next thing, that is your SNAR reaction mechanism. This is one of the important reaction mechanism of this chapter. ठीक है, it is known as nucleophilic aromatic substitution. So there are two different mechanisms for your SNAR. Okay, so the first mechanism is your Meissenheimer complex. So what happens is we will understand about this reaction in a while. ठीक है, अपन इसके बारे में समझने का ट्राई करते हैं. बट फर्स्ट चीज़ें देखो, अपने को पता है कि जो अपने ना जो हेलोजेंस होते हैं दे आर गुड लिविंग ग्रुप, राइट. सो अपन ऐसे रिएक्शंस कर पा रहे थे जहाँ पे वी वर हैविंग CH3 CH2 chloride. Let's take the normal alkyl halide and if we react this with CH3O negative, तो यहाँ पे this was attacking on this carbon and this was leaving. Normal आपका substitution was happening, but the thing is अगर if you have a compound like this that is your aryl halide, यहाँ पे क्या होता है ना कि this chlorine cannot leave. This bond, this carbon and chlorine bond is very strong here. Okay, and this carbon is a sp2 carbon. So it is more electronegative, right, than the normal carbon. Okay, okay, so this bond between carbon and chlorine is very strong. This will not break. Okay, so you cannot have normal substitution. If you add a OH negative, this OH negative cannot replace this chlorine. But the thing about your aryl halide is this reaction is favored when there are electron withdrawing group on ortho and para position. ठीक है, so अगर आपके पास ortho पे if you have a -m group, that is your electron withdrawing group, or on the para position if you have a -m group, so अपने को पता है कि अपने जो -m groups है ना, these create positive charge on ortho as well as para positions, है ना. This is the property of -m group, right. So यहाँ पे अगर if I will draw the resonating hybrid, तो क्या होगा, this bond will open up in this direction, will create a positive charge on this carbon. ठीक है, so due to the presence of this -m group we can create a slight positive charge on ortho as well as para position. यहाँ पे भी you will have a slight positive charge. So the thing is कि if you have these type of group increases will improve this reaction, that is your nucleophilic aromatic substitution. So in the case of Meisen-Heimer complex, what we do is we need, first thing that we need is we need a minus M group on ortho or on the para position. So this is very important. So you need a minus M group on these positions. So once you have this group, now what we will do is we will try to understand the reaction mechanism. So क्या करते हैं अपन first case लेते हैं. We will see this case where the NO2 is present on the ortho position. ठीक है. Here we have a chlorine, here we have a NO2 group. So as I have told you कि let's say the nucleophile that here we have is OH negative. Okay, so we have this as the nucleophile. Now since we have a minus M group, this can create a positive charge on this carbon by shifting this double bond here. So this double bond will shift, creating a negative charge here. है ना? We have this negative charge here. Now this OH can attack here. यहाँ पे आपके पास positive charge है. This OH can attack here. So इसके attack के कारण you will get this as the final product. यहाँ से we are generating this thing, NO2. We have a negative charge here. We have a chlorine here as well as we have a OH here. So this thing is known as your Meisen-Heimer complex. Okay, so this is the intermediate that we are forming. You can also call it as Meisen-Heimer intermediate. Okay, so this is known as your Meisen-Heimer intermediate. Now the thing is, since this is not that stable, since it is an intermediate, this step is the rate determining step. Okay, so this is the rate determining step. We have reached to the Meisen-Heimer complex. Okay, we have reached to it. Now देखो अभी क्या है कि अपना जो starting compound था ना, this was aromatic, but due to the formation of Meisen-Heimer complex, it has lost its aromaticity. But we know that the compounds try to become aromatic, so what it will do is it will try to get back its aromaticity. So this negative charge will push back. So once this negative charge will push back, now this chlorine can leave, right? So once this chlorine will leave, you will have this as the final product. You have got the aromaticity back, you have OH here and you have NO2. So in the case of aromatic compound, to get the substitution, you need a minus M group. ठीक है. So this minus M group is creating these charges. Similarly, अगर अपन ने इससे start किया होता तो you could have got this thing. Okay, so I hope this process of Meisen-Heimer complex is understood by everyone. This is very important. You will see this mechanism in very detail in the rest of the chapter, that is your alkyl halide, है ना? Sorry, your alcohols and aldehyde ketones too. ठीक है? So I hope this process is understood by everyone. So now try to solve this. We will try to solve this question. This is a very good question. So what you have is, you have this as the substrate. This is the substrate that you have. Okay, and we are adding CH3O negative. So आपको बस ये decide करना है कि out of these two halogens, which one will be removed by this nucleophile. Okay, the first thing that comes to our mind is, देखो कि अपने जो फ्लोरीन्स होते हैं ना, they are not good leaving group. Basically they are poor leaving group. Generally अपने जो bromine है ना, they are good leaving group. But the thing is, that is the case in normal alkyl halide, but this is your aryl halide. So यहाँ पे these bonds are very stable. To break this bond, it is very difficult. Now the thing is, since you have a NO2 group here, this NO2 group is creating positive charge on ortho and para position. So you have a positive charge on ortho and para position. So due to that, what will happen is this negative charge will attack on this position and your fluorine will leave, even though fluorine is not a good leaving group. In this case you will create a species where your fluorine is leaving instead of the bromine. Okay, so this is the final product that we are getting. This is the major product that we'll be getting. It's very difficult to replace this bromine because it is on the meta position. You don't have positive charge on the meta position. So we have just understood everything about the reaction of SNAR. So this was the one method that is known as Meisen-Heimer complex, in which the only condition is you need a minus M group on the meta position. Okay, so here are the few points that we have just discussed abhi. Okay, that your halogen atoms which is ortho or para with respect to electron withdrawing group is replaced. So यहाँ पे अपन ने समझा कि since fluorine was present on the para position, it got replaced even though it is a poor leaving group. Okay, so this is important. Next thing is more the number of electron withdrawing group, faster nucleophilic substitution. So it means that if you have 2 NO2, so let's say we have a fluorine here, and we have a NO2 on the ortho position, and you have NO2 on the para position. So in this case, if we are using a OH negative in the solution, this fluorine will leave faster than this one, where you have only one NO2. Okay, so if you have more minus M group, आपके reaction will be more faster. ठीक है, so this NO2 is ortho to this fluorine and this NO2 is para to this fluorine. So this is again very important, that the more number of electron withdrawing group will increase the nucleophilic substitution of aryl halides. ठीक है, so attack of nucleophile at deficient carbon is rate determining step. So अपन ने ये भी समझा कि अपना जो ये स्टेप था ना कि OH का अटैक करना on this carbon was the rate determining step, है ना, because we were forming this Meisen-Heimer complex, है ना. Since it is a complex, यहाँ पे we have lost the aromaticity. This is not that stable. So this step is the rate determining step. So that is the same thing that has been written here. So we have discussed all of these things. Next thing is, this is very important. So we are studying the two different mechanisms for your SNAR reaction. We have studied about Meisen-Heimer complex. Next is your benzyne mechanism. So just wait for a minute, guys. Okay, so this only happens when there is a presence of very strong base. So if you have a base which is like NH2 negative, this is very basic, right? You can use something like this, NaNH2. So this is eventually providing us with a NH2 negative, which can act as a base. So if you have a base like this one, तो यहाँ पे ना कुछ और ही हो रहा है यार रिएक्शन में. तो यहाँ पे क्या हो सकता है, यहाँ पे क्या हो सकता है कि देखो, this is the alpha position, this is the beta position. On the beta position you have a hydrogen, right? So since it is a very strong base, so what can happen is this base can capture this hydrogen. So this base will to create this thing. To create this thing where you have a negative charge on this carbon. So as soon as you are creating this negative charge will make this chlorine leave. So you will have a positive charge here, and finally you will have a triple bond here. ठीक है, so you आप ऐसा imagine कर सकते हो कि that you are creating a species like this. ठीक है, actually में ये नहीं होता है, this is just imaginary. So finally you can assume we are creating. So देखो, this is just a mechanism. We don't know for sure that there is a formation of benzyne. So it's just that कि the formation of benzyne explains the theory of everything, that get formed in this reaction. So we are creating, so that is why we have accepted the concept of benzene. We are not still sure about this, ठीक है. So study is still going on this topic. So देखो यहाँ पे ना, यहाँ पे देखो इसका ये अपने को समझ में कैसे आया कि let's say in the starting reactions, देखो अब ना, now if you add NH2 negative to it, so what will happen is you will create a species like this. You will have the normal benzene ring, and किसी एक पोजीशन पे you will have NH2, right? And जहाँ पे negative charge आया तो we can add a hydrogen from the solution, right? Now the thing is कि scientists try to do this experiment with different things. So देखो यहाँ पे let's say one of the carbon that we have, let's say this carbon which is bonded to chlorine is a carbon 14. Okay, so we are starting with a carbon 14. So what will happen here कि after this benzene has formed, so this was the carbon जिसके ऊपर जो carbon 14 था, right? So now the thing is I will erase this product. Now the thing is when your NH2 negative will attack on this species, so this NH2 negative can either form a bond with this carbon or it can form with this carbon. The possibility of forming the bond of NH2 with these two carbons are equal, right? Because this bond can either polarize in this direction or it can polarize in this direction. So on that theory, you will get two products from here. One is this one, where this carbon is carbon 14 and your NH2 is here, while the other product is this thing. This is your carbon 14 and your NH2 is present here. So you will have both the product and 50-50% in the solution. Okay. So that is how we came to understand कि okay, maybe the reaction will be happening via your benzyne mechanism. So these two were the two important reactions in your SNAR. The first one was your Mesenheimer complex, ठीक है, and this is the second one is your benzyne mechanism. So let's try to solve few questions on this topic. देखो, so the thing is देखो यहाँ पे this base can take out the hydrogen from here only. You don't have any hydrogen here, right? So यहाँ से the benzyne that you will be creating here will look something like this. So you have CH3 here. This is the benzyne that you will be creating. Now the thing is, now when your NH2 negative will attack on the species, you can have two different products. So in one case you will have the NH2 on the ortho position to this CH3, while in the second case you will have this NH2 on the meta position to this CH3. Okay, so we always talk about ortho para position with respect to one of the group. So with respect to CH3 this is ortho position, and with respect to CH3 this is the meta position. Okay, so I hope this part of the reaction is clear to everyone. Okay, chalo. Now we will see one question. So what we will do in this question is, you need to prepare this acid from this alcohol. So you need to use the concept that whatever we have learned till now in this chapter. We have learned a lot of things in this chapter. So you need to use any of those concepts to convert this into this thing. चलो देखो, फर्स्ट थिंग, सिंस वी आर डूइंग द चैप्टर ऑफ अल्काइल हाइड और अपने को पता है कि यू कैन प्रिपेयर ग्रिनियार्ड रिएजेंट फ्रॉम योर अल्काइल हाइड दैट इज यूज टू इंक्रीज द नंबर ऑफ कार्बन इन द प्रोडक्ट. सो अपने को ऐसा सोचना है कि हाउ टू कन्वर्ट दिस इनटू एन अल्काइल हाइड. Okay, so one way to convert this into an alkyl halide. So let's say we are simply adding HCl2. Okay, adding this HCl, what it will do is, the first thing it will do is it will protonate this oxygen. And now it has become a good living group. So it will leave to form this alkyl halide, that is your this thing. Now you can simply add magnesium to it to create an Grignard reagent, that is something like this, MgBr. Okay. Now we have seen the reactions of Grignard reagent with CO2. है So once you add Grignard reagent to CO2, what we create is we create carboxylic acid. That is the same thing that we want here. So if I will draw the structure of CO2, and we know that from here we will create a thing that will look something like this. This can attack on this carbon and one of the bond can open up. So you will have the structure. Okay, मैंने थोड़ा गलत draw कर दिया यहाँ पे. Okay, this is the thing that you will generate. This will attack on this carbon. Okay, to form. Okay, once you have reached here, आप यहाँ तक पहुँच गए. अब normally you just need to add an H plus to get this final acid. Okay, so I hope this process, ये वाला process आपको समझ में आया. गौरव भारद्वाज. Hi Gaurav. Okay, so we have covered two reaction mechanism. One was your Mesenheimer complex. Okay, the only condition here was you needed a -M group on ortho and para position. ठीक है. Next we have studied the concept of benzyne mechanism. So the thing here is you needed a very strong base which can take out a hydrogen from this position. Okay. Yeah, Gaurav, I am not taking classes on the Plus platform. Okay, right now. Maybe I'll be starting taking classes very soon. So right now I am only teaching on this YouTube channel and in my special classes. Okay. So generally मैं try कर रहा हूँ कि मैं यहाँ पे ही सारी चीज़ें cover कर दूँ. Most probably I will start taking classes from the next month. So you have taken the Plus subscription, I guess. Okay, so we have also talked about the benzyne reaction mechanism. Okay, so both of these things are covered. So this is the last session of the alkyl halide. We are just going to finish this session. Okay, so we have seen these cases. Now the next thing is we will be solving few questions in today's session, and after that I will end our today's session. Before I am ending this session, the thing is, देखो, from tomorrow we'll be starting a new topic, that is your alcohols and phenols. Okay, and that tomorrow is 14th, I guess, right? So from 14th we are starting this thing, and from 15th we'll be starting S block. So we'll be doing organic and inorganic on alternate days. ठीक है. So this is in your 12th standard, and this is from your 11th standard. And in my special classes, we'll be revising the chapter of periodic properties by solving a lot of questions. So I have taken one session on periodic properties today itself, today at 2:30 p.m. So the timing for this session is 2:30 p.m. Okay, so we will finish the chapter of periodic properties. After that we will be doing the chapter of chemical bonding. Chalo, I hope everyone is clear with the schedule. Next thing is, I want everyone to solve this question. So what is happening here is we are taking a Grignard reagent and we are reacting with this thing. So you need to tell the final product in this case. So अपने को पता है, first thing that we know is Grignard reagent finally provides us with a R negative. So here we will be getting a CS3 negative. This can either act as a base or it can act as a nucleophile, right? So these are the two possibility it has, right? So here what will happen is, देखो, we have also studied कि whenever you are doing the question of Grignard reagent, you should always check for acidic hydrogen, है ना? Because these Grignard reagent has a tendency to act more as a base, so it will react as a base before it will react as a nucleophile. We need to check for acidic hydrogen. Now since we have a carbon which is bonded to three triple bonded, so this hydrogen is very acidic, so your CS3 negative will simply react with this hydrogen to form CH4. This is the final product that you will be getting from here. Okay, so I hope these things are clear to everyone. So the concept of Grignard reagent is very important. So always remember that you should check for acidic hydrogen. Chaliye, next thing, try to solve this question. So the reagent for the following reaction, what you need to do is, आपके पास you have two bromines, right? You need to use a particular reagent to convert it into triple bond. So there is one more question after that. So just try this question. I'll be back in 10 seconds. Okay, so I guess you guys must have tried this question. So देखो यहाँ पे we know that we want to replace this bromine, right? So we want to create a triple bond. The normal thing is you can simply add alcoholic KOH followed by NaNH2. Simply this thing is making this bromine leave to create a triple bond, है ना? तो यहाँ पे अपने को पता है कि all of the bromine needs to be removed from these two positions, and finally you will be getting the triple bond. So the correct answer here is B. Okay, so this is the last question of our today's session. Okay, now the thing is, Ki in acetone undergo SN2 reaction with each of PQRS. The rate of the reaction vary as. The first thing that we know about the SN2 reaction mechanism is it favors 1 degree, then 2 degree, then 3 degree, and at the top you have CS3X. Okay, so I'm giving you 30 seconds to try this question. Okay, now the thing is, देखो यहाँ पे we know this is the general order, but the correct answer here is B option. The reason is, देखो SN2 reaction में what we create is we will create I negative, right? So this I negative is a nucleophile which can attack on a carbon which has a positive charge. Now the thing is, देखो on this carbon which is bonded to this chlorine, you have a lot of positive charge because of this further, because the first thing is because of this chlorine, and the second thing is you have a double bonded oxygen here. So this has a tendency to open up. If it will open up, it will create a positive charge here, which eventually create a partial positive charge on this carbon, right? So this carbon has a lot of positive charge here. Okay, so the first thing is this iodine will attack on this carbon and this chlorine will leave. So out of all of these options, in this case the SN2 reaction will be faster. ठीक है, even though this is the order, है ना, this is a 1 degree carbocation, sorry, this is a 1 degree alkyl halide. Okay, this is your normal thing. So out of all of these, the maximum rate will be in the case of S. Baki in all of those cases you can just check. This is the case of your CH3 chloride. In this case the rate will be faster than this one and this one. Okay, so that is why the correct answer here is B. So with this guys, we have completed everything in the chapter of alkyl halide. Okay, so from tomorrow we'll be starting, I have already written these things in the previous pages. We'll be starting alcohols and phenols. Okay, so on the alternate days we'll be taking organic and inorganic. So these are the two topics that I'll be starting from tomorrow onwards. Okay, and in my special classes we'll be solving a lot of questions on these topics. So with this, I'll be ending our today's session, and I have already told you about the plus and the iconic subscription. The cost for the plus subscription for a 1 year plan is 34,650 after you have got this 10% discount, and for a 2 year plan it is 50,400. Okay, and for the iconic subscription it is 50,400 for a 1 year plan, and for a 2 year plan it is 77,400. Okay, so again feel free to use my code which is AC01, which is providing you with a 10% discount. I hope all of these things are clear to everyone. So the chapter of alkyl halide was very important because this is the one of the starting chapter, organic chapter in our 12th standard, and we have seen कि अपने GOC का use भी बहुत आता है in this chapter. And I will not be teaching hydrocarbons separately as we have covered the major portion of hydrocarbons in this chapter only. Okay, so with this I will be ending our today's session. Do subscribe to our channel, that is Let's Crack JEE. Use my code AC01 to take any of the Unacademy subscription. Press the bell icon to never miss a video from us. Okay, thank you and bye everyone.